All right, so let's look at an example of balancing redox reactions in basic conditions. So balancing redox reactions in basic conditions are the same steps as acidic conditions, but the very last step is adding hydroxide ions to both sides to neutralize the hydrogen ions. This will produce water, and then you will cancel out as many waters as you can. Okay, so let's look at an example. Okay, so we have the plumbite ion, which is PbOH3 minus, which is aqueous, plus the hypochlorite ion, aqueous, produces iron 2 oxide, or just iron, iron 2 oxide. Sorry, iron 1 oxide. Aqueous, plus the chloride ion. Okay, so let's work through this. So first we are going to identify what's being oxidized and what's being reduced. So this plumbite ion here, I know that hydroxide has a charge of -1, and I have 3 of them, so that's -3, and it has an overall negative charge, so I know that this iron right here must be +2. This iron right here, because I have oxygen, which has a charge of -2, and I have 2 of them, that means this iron here must be +4. So that means iron is going from +2 to +4. Iron is being oxidized. Now let's see what's happening to the chlorine. The chlorine here has a charge of -1 because this is a monatomic ion. Here, this oxygen has a charge of -2. So what plus -2 is -1? This must have been +1. So it's going from +1 to -1. That means this is being reduced. So let's look at the oxidation half reaction. So this is a little bit different. This is in basic conditions. So in the problem, it would either say it's in basic conditions, or above the arrow it would say basic, or there would be a hydroxide above the arrow. So it's basic conditions. So the oxidation half reaction So same order. First, you need to balance the element that is being oxidized. It's already balanced. 1 lead, 1 lead. Next, you need to balance, and I'm just going to do these all kind of together instead of step by step just to save space. But I would encourage you to do it step by step and then come back and make sure that you're able to do it. Okay, so let's change colors maybe. Okay, so the elements are balanced. Check. Next, so I'll just maybe write out the steps over here. So balance elements, oxygens, hydrogens, charge, and then add half reactions together. Then we are going to add hydroxide at the end. Okay, so elements are balanced. Lead, lead. Next, oxygens. This side has 3 oxygens. This side has 2 oxygens, which means this side needs 1 water. Oxygens balanced. Hydrogens. This side has 3 hydrogens. This side has 2 hydrogens, which means this side needs 1 hydrogen. Hydrogens balanced. Charge. This side has a charge of -1. This side has a charge of +1, which means this needs 2 electrons. Remember, we're not trying to get the charge to equal 0. We're trying to get the charge to be the same on either sides of the arrow. So if this is +1 and this is -1, I need 2 electrons over here. So now this oxidation half reaction is balanced. This is the oxidation half reaction. So now let's look at the reduction half reaction. So the reduction half reaction is this hypochlorite ion to the chloride ion. Okay, first things first, we're going to balance the elements. Done. 1 chlorine, 1 chlorine. Then we're going to balance the oxygens. Well, this side has 1 oxygen, so we're going to give this side 1 oxygen. Now we're going to balance the hydrogens. This side has 2 hydrogens. Let's give this side 2 hydrogens. When we give this side 2 hydrogens, now we make this side +2 -1. This side is +1. This side is -1. Now I need to give this 2 electrons. Now the charge is balanced. So now this is my balanced reduction half reaction. So now we need to add these 2 together. And it just so happens that I have the right number of electrons on either side, so I don't need to do anything. So I'm going to add these 2 together. So I'm going to say 1 hydrogen, 2 hydrogens. So this hydrogen here is going to cancel one of these hydrogens. So I'm going to have 1 hydrogen plus this hypochlorite ion plus this plumbite ion produces, I'll say, the chloride ion plus how many waters? 1, 2. Remember, everything that's on the same side of the arrow you add together. Opposite sides of the arrow cancel. So this is +2 water plus the lead oxide. Okay, so this would be done if we were in acidic conditions, but we're not in acidic conditions. We are in basic conditions, and basic conditions say that we add hydroxide to both sides to cancel all the hydrogens. So however many hydrogens there are, that's how many hydrogens you would add to both sides. If there were 10 hydrogens here, you would add 10 hydroxides to both sides. There's not. There's just 1 hydrogen. But however many hydrogens there are, you're going to add that many hydroxides. So I'm going to say plus OH to that side and plus OH to this side, aqueous. Aqueous. So when we add the hydroxide here, hydrogen plus hydroxide equals water. So I'm just going to write it out. 1 water liquid plus the hypochlorite ion plus the plumbite ion gives me the chloride ion plus 2 water plus lead oxide plus the hydroxide ion. So now I have water on both sides of the equation. And maybe you recognize that here. I just wanted to write it out to show you. So this one water on this side is going to cancel with one of these waters on this side. So now finally what I'm left with is the hypochlorite ion plus the plumbite ion produces the chloride ion plus one water plus lead oxide plus hydroxide. And this is the balanced redox reaction for this reaction in a basic condition. If it's a basic condition, then you will see a hydroxide in the balanced equation. Just like if it's an acidic condition, you will see hydrogen ions in the balanced equation. So this one was also acidic condition, so you see hydrogen ions. The difference between the basic condition rules and the acidic condition rules are you go all the way to the end after you've added the two half reactions together to get rid of the electrons. Then you go in and add the hydroxide to neutralize however many hydrogen ions you have. That is going to form a water. You'll cancel however many waters you have on the other side, and that will result in your balanced reaction in a basic condition.